everybody, and welcome to our lesson on finding zeros of polynomial functions. The zeros are going to be those places where the polynomial function crosses the x-axis, so sometimes they're called x-intercepts or roots. And one thing you should know when you're starting to find the zeros of one of these functions is that you should come up with as many zeros as you have in the degree number. So if you're looking at a polynomial of degree 5, then you should find 5 zeros. If it's degree 3, there should be 3 zeros. They won't always be real. They may or may not be real. Some of them could be imaginary zeros, but they will have that many. Alright, so to start finding the rational real zeros, you can use something called the rational root theorem. And that just helps us narrow down our list of things to try if we are not able to look at a picture, a graph of our function. And what it is it states that every rational root is going to come from a list that is made from the factors of your constant term, so you have to look through your polynomial and find that number, divided by the factors of the leading coefficient. We're going to take a look at this, and it's really just used to help us narrow down the choices for what could be rational roots. So let's say we're taking a look at this cubic polynomial function here, and I need to find out the roots, or the zeros. So I'm going to try to narrow it down first. I'm going to look at my constant term and my leading coefficient. This is in standard form, so my leading coefficient is in the very front. There is no number there, so when that happens, there's a little implied 1. Always. Alright, so what are the factors of 6? We have to think about the things that 6 can be divided evenly by. And that's going to be 1, 2, 3, and itself, 6. Alright, and what are the factors of 1? That's pretty easy. Plus or minus 1. I'm putting plus or minus because we have to consider the negatives of these numbers also. Alright, so what this means is that the possibilities for rational roots for this polynomial are going to be 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Sometimes you'll have other numbers down there besides 1, so you want to split up each top number over each bottom number to get all the possibilities. So we don't have too many. We've got 8 possibilities here. So let's just start off by testing one of these. Let's just start at the front of the list, and let's test -1 using synthetic division. This is a good method to help us figure out if what we're looking at is a root or not. We're going to set up some synthetic division here, and the way we have to do that is we need to put the number we're testing on the outside of this sort of upside down division bar, and on the inside top row we're going to fill that in with our coefficients. So our coefficients in standard form were 1, 2, -5, and -6. We're going to go fill that in. And synthetic division is just sort of a process of adding and multiplying across this row until we get to the end. And what you want to do is you want to bring down your front coefficient under the bar and begin multiplying by this -1 and then adding down your column. So we're going to take -1 times this 1 and place it here. And then we're going to add down this column and place it here. So 2 plus -1 is 1. Alright, we're going to multiply again. You'll start to see this pattern. -1 times 1 is -1. And we're going to add down this column and have -6. And go back to our multiplying. -1 times -6 gives me +6. And here we have ended with -6 plus +6, which is 0. Now this is special because when we end on a 0, that means the number we tested is a 0. So that's easy to remember. If you don't get a 0 there, then the number you tested is not a 0. You must get 0 when you finish in this location here. Alright, so we just found out that -1 is a 0 of our polynomial. So now we're going to find the rest of them. Alright, so we know -1 is a 0, and at the bottom row of our synthetic division, we had the numbers 1, 1, and -6. Okay? And what we can do with that is we can make another synthetic division and continue to test possibilities from our rational roots list, or we can fill in the new polynomial here that we have divided to, and then factor. If you're at a quadratic, you can go ahead and factor. So remember, our polynomial was degree 3. We divided, and now it's smaller, so now it's degree 2. Okay, so you can start by filling in one power less down the row. So that would be x squared. This would be x to the first, and the 6 would have no x. All right, so x squared plus x minus 6. Now I have a quadratic, so I could continue and factor this to find the other zeros if it's factorable. All right, so to factor, I'm looking for the two numbers that will multiply to give me negative 6 and add to give me positive 1. And that is going to be 3 and 2, and I want my 1 to be positive, so I'm going to use positive 3 and negative 2. See how the product 3 and negative 2 will give me negative 6, and the sum of those numbers will give me positive 1, my middle number. All right, these are my factors of this new quadratic, so I'm going to set each one equal to 0 and find the 0. All right, x plus 3 equals 0 means that x equals negative 3 when I solve for that one. And x minus 2 equals 0 means that x is 2. So we just found 3 zeros, or roots. Remember, negative 1 was one of them, and we just found 2 more. And in the beginning of the lesson, we said that our number or amount of zeros should match our degree. And if you remember the degree of our polynomial when we started, it was a degree 3. So we have found all 3 zeros. There won't be any more. So that's how to use synthetic division and then move to factoring to find your zeros. All right, so let's say we need to go ahead and express our polynomial in factor form. Well, that's just going to look like our factors kind of grouped together. So 2 of them, remember, was x plus 3 and x minus 2. And then our third one is going to be x plus 1 because the root of that expression was negative 1. Factor form is just simply all of our factors written together. And if you were to multiply this form out, you should come up with our original polynomial that we saw on the first slide, the x cubed slide. All right, here's another example. Here is an example of finding our zeros using special products. So this time we're not going to create a rational root list for possibilities because I can see that this is a difference of squares, meaning two things that square perfectly to give me these two terms. So I'm going to use difference of squares factoring here and then continue to solve from that point to find my zeros. So the groups that I'm going to use are the first two spots need to be the first two things that multiply to give me x to the fourth, and that's x squared and x squared. Think about x squared times x squared is going to give me x to the fourth. And then in our last two spots, we're going to have to place the two things that would multiply to give me 16. It's got to be the same number, so I'm going to use 4. And one gets to be a positive and one negative because I would like for that product to end up being negative 16, as I can see in the original expression. All right, so if these are my factors, how do I find my zeros? Well, just like we did in the previous problem, we're going to set each one equal to 0 and then solve. So I'm going to have x squared plus 4 is 0 over here, and x squared minus 4 is 0. And I'm going to solve. I'm going to move things away until I have x by itself. So this would become x squared equals negative 4, and this would become x squared equals 4. Now, I don't care about x squared, I just want x. I want what are the x values. So I'm going to take the square root of both sides on each one. And you can see that in this first one, I'm not allowed to take the square root of a negative unless we turn this into an imaginary number. That's what this becomes. So the square root of 4 is 2, but since it's a negative 4, it's going to be 2i. So I've got plus or minus 2i coming from that one. And then over on the right, square root of 4 we know is 2 plus or minus regular 2. So right here I've got 2 zeros, and right here I've got 2 zeros. And take a look at our degree. It's degree 4, so we have found all 4 of our zeros. There won't be any more. And this concludes our lesson on finding zeros of polynomial functions.